All right, today we are diving deep into a piece of tech that totally changed the game for databases. I mean, it took them from being a simple filing cabinet to being a living, breathing map of the world and all its connections. We are talking about Oracle Spatial and Graph. So let's just start with this one simple question. How in the world do you put a map inside a database? Seriously, think about it for a second. A map isn't just a tidy list of names and numbers, right? It's all about shapes, locations, routes, areas. It's messy, it's complex, and it's nothing like a spreadsheet. And that right there gets to the very heart of the problem. For decades, databases were absolute pros at handling rows and columns, perfect for things like customer lists or sales numbers, but they had zero, and I mean zero, native understanding of geography. The real world, with all its spatial messiness, was just a completely foreign concept to them. So this huge limitation really set the stage for a new way of thinking, a big push to move way beyond those basic rows and columns. And man, was this a challenge. How could you possibly ask a database a question like, hey, show me all my delivery trucks that are driving through this specific neighborhood right now? Or how are all the different parts of my city's power grid connected to each other? Your standard database language, SQL, just couldn't handle concepts like location, distance, or how things are networked together. To crack this nut, Oracle came up with a really powerful two-part solution that they built right into the core of their database. And this breaks it down perfectly. On one side, you have Spatial, which is all about the where. It basically teaches the database geography. Then on the other side, you have Graph, which is all about the how. How things are connected. Spatial tells you the location of two cities. Graph tells you about the highway that connects them. See the difference? It's pretty brilliant. So how did they pull this off? Well, the first step was to create brand new data types. A point could literally be a single coffee shop. A line could be a road or a river. And a polygon could define something like a county border or a sales territory. These became the Lego bricks, the fundamental building blocks for creating digital maps right inside the database itself. Now, storing the map is one thing, but you have to be able to ask questions about it, and you need the answers fast. This is where spatial indexing comes in, and it's the absolute secret sauce. It's this super clever system that lets the database instantly zoom in on a tiny geographic area, instead of having to scan through millions and millions of locations one by one. It's the reason your phone can find the nearest pizza place in, like, half a second. And this wasn't something that just appeared out of nowhere fully formed. This technology grew up and matured over many years, with each new version of the Oracle database adding some seriously powerful new features. Let's just walk through how this whole thing evolved. It really kicked off in the early 2000s with Oracle 9i, which laid the foundation with core GIS features. Then with 10G and 11G, it got a lot smarter, adding things like 3D data and support for raster data. That's the stuff satellite images are made of. But the really massive leap, the game changer, came with 12C. That's when the graph side of the equation was fully brought into the fold for analyzing super complex networks. And today, it's a core piece of Oracle's cloud, powering geospatial analytics on a massive scale. Okay, so we've got the tech, we've got the history, but what did this actually do for people? What was the real-world impact? And here's the most important takeaway. This wasn't just some neat new feature. It was a fundamental shift. Companies no longer needed a totally separate, specialized, and expensive system just for their mapping data. All of a sudden, location intelligence wasn't some add-on. It became a core part of the data, living right there next to all their customer and sales info. And as you can imagine, this completely transformed industries where geography is everything. Think about it. Transportation companies could suddenly optimize their shipping routes on the fly. Utility companies could map out their entire power grid and pinpoint an outage in seconds. And telecoms, they could analyze cell signal strength to figure out the absolute best place to build a new tower. Just incredible. And I think this quote just nails it. This technology literally changed the identity of the Oracle database. It stopped being just a place to store information and became a platform for actually understanding the real world, for making maps and for analyzing the incredibly complex networks that power, well, everything. Which leaves us with a pretty fascinating question to think about. Once your data understands not only what it is, but where it is and how it's connected to everything else, what new possibilities open up? This very foundation is what's powering so much of our world today, from smart cities to AI-driven logistics. So what happens next when every single piece of data truly knows its place in the world?